Hi, this video is the second video for Lecture 3. For this video, I will talk about perpetuity and annuity. Perpetuity will provide you with a string of equal payments frequently, and these payments will continue forever. For example, if you have a $100 perpetuity that pays at rate 5%, then you will have $5 every year. The cash flow of this perpetuity is $5 at the end of every year. How do we know the present value of this perpetuity is $100? Let's see a simple example to understand the concept of perpetuity. Suppose you have $100 in your hand and you save this $100 in a bank account. Now you decide to regularly withdraw $5 from your bank account. The interest rate is 5%, so now we can calculate the cash flow for 2 years. In year 0, you have $100 in your bank account. After 1 year, the $100 grows to be $105. Now you decide to withdraw $5 from your account. You have $100 remained in your bank account. 1 year after, the $100 will grow to be $105. Then you can also withdraw $5 from your bank account. For the remaining $100, you can decide to leave it in your bank account, or you can withdraw the $100 and buy the movie tickets. So the cash flow will be $5 in year 1 and $5 in year 2 plus $100 in year 2. Now let's consider a crazy saving plan. You save $100 in the bank and you never withdraw the $100 from your bank account. Alternatively, you regularly withdraw $5 as interest from your bank account. So you basically repeat the previous slide again and again. This saving plan will give you $5 every year. Let's verify it is true. In year 0, you have $100. 1 year after, it grows to be $105. You pick up $5 from your bank account. So you have $100 remained in your bank account. 1 year after, that is year 2, the $100 will grow to be $105. Again, you pick up $5 from your account. You have $100 left in your bank account. Then in year 3, the $100 grows to be $105. You withdraw $5 from your account. You still have $100 remaining in your bank account. Again, this $100 can grow to be $105 in year 4. In year 4, you can withdraw $5 from your account and leave the $100 in your account. You iterate this process again and again and never end. Then you can have $5 at the end of every year. So this is the cash flow of a perpetuity. You regularly have $5 from your bank account, and this payment will continue forever. This example gives us the intuition of perpetuity. We can use this relationship, this imagined saving plan, to back out the present value of perpetuity. The present value of perpetuity is the cash payment divided by required discount rate. In this previous example, we have payment at $5 and interest rate at 0.05. So it is equivalent. If you can receive $5 payment every year forever, it is equivalent with saving $100 in your bank account and never withdraw the $100 from your account. So the equation for calculating present value of perpetuity will be the present value of perpetuity equals payment over interest rate. Okay, now I want to introduce another kind of cash flows, that is annuity. Annuity will give you equal payments frequently for specified number of periods. For example, you buy a car and you need to pay a car loan. The car loan requires you to pay equal payments during the next 48 months. The car loan is a typical annuity product or annuity cash flow. Here in this video, I will talk about a more simple annuity cash flows. These two-period annuity cash flows will give you $5 1 year after and $5 2 years after. Now here's the question: how can we know the present value for this annuity cash flow? Well, we talked about the discounting process in the first video of Lecture 3. Here we can use the discounting process. We have two cash flows in this annuity. The first cash flow will be $5 1 year after. The second cash flow will be $5 2 years after. We can calculate the present value of these two cash flow and then combine them together. In this way, we can calculate the present value of this two-period annuity. So here, the present value for $5 1 year after will be $5 divided by 1 plus 0.05. The present value for the cash flow 2 years after will be $5 over 1.05 to the power of 2. Then we combine them together. It is $9.3. So the present value for this two-period annuity is $9.3. Can we find a better way to calculate annuity? Yes, because we have a beautiful relationship between annuity and perpetuity. So here I provide a cash flow starting from year 2. These cash flows will give you $5 in year 3, $5 in year 4, and this payment will continue forever. Starting from year 2, these cash flows is a typical perpetuity. Now I want to add another cash flows. These cash flows will give you $5 in year 1 and $5 in year 2. So this cash flow is a typical annuity. Now if we combine these cash flows during year 2 and year 1 and the cash flows during starting from year 3, what do we get? We get a whole new perpetuity. So we can find the perpetuity can be split up into annuity plus a delayed perpetuity. This equation will be very useful to construct the present value of annuity. In fact, we can use the present value of annuity as the difference between a present value of perpetuity and the present value of delayed perpetuity. The present value of perpetuity starting from next period will be the payment over interest rate. The present value of a delayed perpetuity will be the present value of new perpetuity times the discount factor for this delay. Because the annuity lasts for 2 periods, so we set the discount factor to be 1 over 1 plus r to the power of 2. So in this way, we use the difference of this perpetuity value starting from next period and the present value of delayed perpetuity starting from year t plus 1 as the present value of annuity. If you do some algebra calculation, you can write the first equation into the second equation. The second equation tells us the present value of annuity can be payment multiplied by the difference between 1 over r and 1 over r multiplied by 1 plus r to the power of t. We call this formula as the present value annuity factor. You can use this present value annuity factor to do calculation very quickly and easily. In the previous example, the payment is $5, the interest rate is 0.05. So you can verify the calculation with this formula. Trust me, the number will be $9.3. It is exactly the number we calculated in previous slides. Okay, now I want to give a brief summary for the second video. In this video, I talk about perpetuity. Perpetuity will give you equal payments frequently forever. I also talk about annuity. Annuity will give you equal payment regularly in a specified time interval. We can always use perpetuity and annuity to have quick calculations for different structures of cash flows. Also, I will introduce the online financial calculator and exercise of Excel spreadsheets to do these calculations of cash flow with the help of these instruments. Thanks.